This was the problem we discussed. We talked about friction again, how the friction works. And we solved this problem, for which you actually needed also the idea of equilibrium of torques. I don't think we have time to solve a lot of problems, but we will solve a few more interesting problems and we will move on. I think question number 1 will be an interesting case. You are being asked to determine the force P to move the block B. You can see that there are 3 blocks here, A, B and C, and you have walls which are mutually perpendicular, and the block A is directly tied to the vertical wall using a rope, and there are 2 other blocks, B and C. C has a weight 200 Newton and other 2 have a weight 100 Newton each. P is the external force applied on block B towards right. Coefficient of static friction between A and B is 0.2. Coefficient of static friction between B and C is 0.2. Coefficient of static friction between C and the horizontal surface is 0.1. Now the question here is, what is the force P required to move the block B? How do we calculate this? So this is the problem. Okay, I think there is an issue. Like I told you, there was a problem with the connection. Let me see if you have all lost the connection or it's just me. I mean, if you are still in the meeting, or now all of you have to join again. Okay, I'm going to continue anyway, because this is something I've told you in the beginning itself. This can actually happen, but we have no choice but to continue the class, and I will upload the lecture on YouTube, where from you will be listening what I'm saying right now. Obviously you are not hearing me. So now the question here is, how do we find out the external force P required to move block B? So usually what we do is that once we have a problem like this, we draw the free body diagram of the blocks under consideration, draw all external forces, and write equilibrium equation using which we will find out the unknown forces on the block. Here we have 3 blocks, so we will plot the free body diagram of which block, A, B or C. So what we do here is that so if we pull block B, there are 2 possibilities. Possibility number 1, B moves alone towards right, and A and C stays there. Possibility number 2 is that B and C moves together, because you can see that B and C, the surface between B and C has a coefficient of static friction 0.2, and coefficient of static friction between the horizontal surface and C is lower than that. So it's also likely that C may also move with B. So there are 2 possibilities. We don't know which will happen if we start applying force P. So we can kind of reframe the question here. What is the minimum force P required to move the block B? So that's the question we are answering here. So we know that frictional force is equal to coefficient of static friction multiplied by normal force, both of which these vector quantities correspond to a pair of surfaces. Now what is the normal force between A and B? And that happens because of the weight of A, which is 100 Newton. So 100 Newton will be the normal force on B by A, and that will also be the normal force on A by B. Now consider this surface. Here normal force happens due to both weight of A and B combined, because both are lying on surface C. So the normal force here is 200 Newton. And here the normal force is due to three of these forces combined, which is now 400 Newton. Now let's consider the first case. Let's assume that when we apply force P, B moves along towards right. In that case, what will be the external force P required? We have block B. External force P. Normal force by A on B is 100 Newton. Normal force by C on B is 200 Newton. So when you are trying to pull B towards right, frictional force will be opposite to it. And value of friction here will be mu n. So mu is 0.2, n is 100 Newton. Here mu is again 0.2. Normal force is 200 Newton. And here I forgot to draw the weight. You also have the weight of the body, which will be at the middle. So I'm just drawing it here, okay, which is 100 Newton. Now it looks like a couple. There is no couple here, okay. This is not causing moment. This should be at the center. For convenience, I'm just plotting here. Now if you consider equilibrium of forces in x direction, P is equal to 0.2 into 100 0.2 into okay. Now this is just the sum of these two frictional forces, and that will be how much? 20 plus 40 equal to 60 Newton. Now if we assume the first case, we get P as 60 Newton. Now if we assume the second case where B and C moves together towards right, let's if B and C moves together towards right, we can consider it like a single system, and forces between B and C will be considered as internal forces, and we don't need to worry about internal forces here. Now here normal force on B is 100 Newton, and force here at C, normal force between C and the surface is 400 Newton. and you have weights here. Weight of B and C are 200 plus 100. I'll write 100 plus 200. Now here you have force P, and friction here is 0.2 multiplied by 100, and friction here is 0.1, not 0.2. Here coefficient of friction value is 0.1 multiplied by 400 Newton. So what is P here? If you simply find the equilibrium equation in x direction, you will get P as 0.2 into 120, 0.1 into 400, 40. So total external force P is 60 Newton. So it seems that external force P required to move B alone and B and C together are the same. Which now means that P value of P is 60 Newton. Connection